Hello, welcome to Graphing 4.6, Graphing Other Trig Functions. This is going to be somewhat of a review from graphing sine and cosine, but now we're going to pick up graphing the other four trig functions. You should have the paper in your notes that looks like this. We've already filled out the sections for 4 or 5. We did those last week when we graphed sine and cosine. So now we're going to go ahead and fill out the sections for tangent and cotangent, secant and cosecant. They kind of come grouped together in pairs. So the first two we're going to talk about is tangent and cotangent. So I'm going to give you a minute to look for that sheet. If you don't have that sheet, you can pause. You can get one from the teacher or from Blackboard. There's some blank ones available on Blackboard. Okay, hopefully everybody has a copy of that sheet, and we're going to go through it. What I've done here is on the left side, on the right side, I graphed these on my calculator. This is what the graph of tangent looks like. This is what the graph of cotangent looks like. So you can see they look completely different from sine and cosine. We have a couple things happening. First of all, if I look at the graph of tangent, I'm going to talk about tangent first. Here it goes way up to infinity, comes down, and then goes all the way down to infinity. But what's important about this is that it happens in a smaller interval. In other words, this is about negative pi over 2, and this is positive pi over 2. And it only takes me between negative pi over 2 and pi over 2 for me to do one complete graph. So when I go to find my period for tangent, on sine and cosine, we took the normal period, which is 2 pi, and we divided it by b. But because our normal period is going to be pi for tangent, I'm just going to take pi and divide it by b, because the new period for tangent is only 1 pi. The second thing that's happening is you're going to have these asymptotes, vertical asymptotes. And the reason why you have vertical asymptotes is because you have places on your graph that where it's undefined. And you talked about asymptotes last year in Algebra 2. It's you found what it was approaching when I hit this pi over 2, and it's kind of like water hitting a wall, and it's gonna like hit that wall and go up the wall. It will never cross that line. That's part of what an asymptote is. So I'm going to figure out what the asymptotes are in this graph, and I am going to plot my points and graph it just like we did before. So my period for both cotangent and tangent will be pi. Both of them I will divide by b to find what my new period is. And again, I'm going to call that new period. So that will be my new period, and this one here will be my new period. To find my step, I'm going to take whatever that new period is, and I'm going to divide it by 4. Whatever that new period is, and I'm going to divide it by 4. What I notice here when I'm looking at the tangent graph, because I have these asymptotes, it's going to be more convenient for me to start my graph at negative pi over 2 instead of 0. So for tangent, I'm going to take that bx minus c that was inside the parentheses, and I'm going to set it equal to negative pi over 2. And then if I'm looking at the graph of tangent over here, I can see that it normally ends at pi over 2. So I'm going to take whatever's in that parenthesis, bx minus c, and I'm going to set it equal to pi over 2. If I look down here at my graph of cotangent, I do have vertical asymptotes, but my vertical asymptotes are going to be in different places. They're going to be here and here. The period is still 1 pi, but I can see that I'm going to have a vertical asymptote at 0, and I'm going to have a vertical asymptote at pi. So I'm going to say that my starting point is going to be bx minus c is equal to 0, just like it was for sine and cosine. And then my end will be bx minus c is equal to 1 pi, because my period is only 1 pi. When I go to do the pattern, what I'm going to do is I know that I'm going to start with an undefined, and I know that I'm going to end with an undefined, because that's the way I set up this interval, is to start at negative pi over 2 and end at pi over 2. Then we're going to hit our new values. What we're doing is we're taking the tangent of negative pi over 4. That would be this dot about here. Then we're going to take the tangent of 0, which would be that dot right about there. And then we're going to take the tangent of a positive pi over 4, and that will be this dot about right here. Well, I know anything with a denominator of 4 is going to be the square root of 2 over 2 over the square root of 2 over 2. So it's going to be 1. And in the third, fourth quadrant, it's going to be a negative 1. So this will be negative 1. The tangent of 0 will be sine over cosine. So it will be 0 over 1. So this will be 0. And then the pi over 4 will be 1. So my pattern for tangent is going to go undefined, negative 1, 0, positive 1. When I look at cotangent, I'm doing the same thing. I'm starting with an undefined. I'm ending with an undefined. So it's going to be u and u. But what's different is I'm doing these points here, here, and here. So my y pattern is going to go 1, 0, negative 1. So the hardest thing that people have is that these are kind of similar, but they're the ones, the negative 1, I'm pointing and you can't see. These two kind of switch places. Other than that, they're exactly the same. And the reason why they're exactly the same is because this point here, I changed that where they start. And I changed it so I could start on an undefined. So let's just take a deep breath and try one. We'll try the basic parent function for tangent first. This should be on that packet. It's called, I don't know what it's called. Hold on. Okay, you have that packet. It's called 4.6 Graphing Other Trig Functions. You will notice that it's probably truly the only thing that I've given you that's really a packet. It has 17 problems on it. My goal today through this video is to go through 4 of them, and then you'll have a couple more to do, and then you'll end up finishing the entire packet at some point. So here we go. I have the tangent of x. So I am going to, this is just the parent function. So my a, color choice, my a is going to be 1. Remember, if you forgot, it's y is equal to a trig function, so we'll use tangent this time, bx minus c plus d. So in this case, my a is 1, my b is 1, my c is 0, and my d is 0. So to find my period, I would take pi and divide it by 1, so I'm going to get pi. To find my step, I take this new period of pi and divide it by 4, so I'm going to have pi over 4. Tangent, I have to remember, I'm going to take whatever's inside this parenthesis, and I'm going to set it equal to negative pi over 2. So I'm going to have x is equal to negative pi over 2. To find my n, because it's tangent, it's different, I'm going to take whatever's in that parenthesis and set it equal to positive pi over 2. When I go down here to complete my table, I just said that I'm starting at negative pi over 2, so that's what I'm putting in here, negative pi over 2. This tells me to go up by 1/4. So this is negative pi over 2, so the next one will be negative pi over 4, 0, positive pi over 4, and pi over 2. And I'm happy because this matches this, and that's what I was expecting, and that's a great way to double check that you know what's going on. The horizontal shift is still the same thing that we did before. Your horizontal shift is still your c divided by b. So in this case, my c is 0 divided by my b, which is 1, so my horizontal shift is 0. My vertical shift is my d, and d is 0, so my vertical shift will also be 0. And now let's complete the table. My y pattern, you're going to go back and you're going to eventually memorize this, but my y pattern is that u negative 1, why am I doing? That y pattern is this u negative 1, 0, 1 undefined. So that's what I'm going to put in here for my y pattern. Now, once I have a u, it doesn't matter what other transformations I have, that u goes straight across, because if something's undefined, it's going to stay undefined if you multiply it by 2. It's going to stay undefined if you try and add 3. It's always going to be undefined. So I'm just going to immediately write those u's across the table. A times y, well, a was 1, so these will stay the same. D was 0, so these will stay the same because this is the parent function. I don't have any vertical or horizontal changes. So when I go to do this, the first thing I'm going to do when I go to graph these now is I'm going to put in my vertical asymptotes. My vertical asymptotes are going to be this negative pi over 2 and this positive pi over 2. So that's the first thing you should do is put in your vertical asymptotes. You're going to draw a dashed line for those. So I'm going to have a vertical asymptote at negative pi over 2 and then one at positive pi over 2. At this point here, since I'm going to have to draw it from multiple periods, I'm going to count. And I have 1, 2, 3 lines in between, right? So I'm going to count again, 1, 2, 3 lines in between, and then I'm going to draw another vertical asymptote. So I'm going to have 1 at 3 pi over 2. I can't fit one on the other end, so I'm going to stop and I'm going to go to the left. 1, 2, 3, vertical asymptote. Cannot fit one over, so there are all my vertical asymptotes. What's different about secant and tangent and cotangent is there's a line that says VA. That VA stands for vertical asymptote. And that we want you to write the vertical asymptotes. So I'm going to go up and look at my graph. I have one at negative 3 pi over 2, one at negative pi over 2, one at pi over 2, and 3 pi over 2. And that's why I draw those lines first, so I can identify those asymptotes rather quickly. Now I'm going to graph what I have. So at negative pi over 4, it's negative 1. So this is negative pi over 4, negative 1, 0, 0, and then pi over 4, 1. And I have those 3 dots. And I know it butts up to the asymptote. So when I go to sketch this graph, I'm going to connect to this point, but then I want it to butt up to that asymptote. And it's going to go the other way and butt up to that asymptote. And that's going to give me my graph of tangent. I'm going to copy that pattern on the next couple places. So I'm going to put this will be my 0. They all have to go in the same direction. And another way to check is I'm going to have 1, 2, 3, 4 lines between my center dots. So 1, 2, 3, 4 center dot. The next one will be to the left, and I'm going to end it like that. I guess I should put arrows on there. So 1, 2, 3, 4, put at center dots. One goes up, one goes down. Sketch my asymptote. Okay. And that's the graph of tangent. So now let's do one of cotangent that has some transformations. So I am skipping ahead to number 7 on your packet. So please look at number 7 in your packet. Okay, this one I have y is equal to 1 plus cotangent 1/4 x. So my a is the number out in front of this trig function, which will be 1. My b is going to be 1/4 because that's what I'm multiplying x by. My c is whatever I'm adding or subtracting inside the parenthesis, which will be 0. And my d is going to be 1 because that's whatever I'm adding or subtracting on the outside. To find my period, it's cotangent, so the normal period is pi, and I'm going to divide that by 1/4. When I take 1 divided by 1/4, I end up with 4 pi, so that's my new period. To find my step, I take 4 pi and divide it by 4, and I end up with pi. To find my start, cotangent is like all the other ones. I'm going to take whatever's in the parenthesis, which is this 1/4 x, and I'm going to set that equal to 0. And when I do that, I end up with x is equal to 0. Then to find my end, I'm going to take that 1/4 x. At this time, I'm going to set it equal to pi because remember the period for cotangent normally is just pi. When I do that math, I end up with x is equal to 4 pi. So my start, I said I start starting at 0. My step says I go up by pi. So I'm going to fill in this chart here. And I'm happy because that 4 pi matches where I thought it would match for my end. My y pattern, if you have to go back and look at it, you can. I start and end with undefined, and then it's going to be 1, 0, -1. I multiply by a. In this case, my a is 1, but I really should have copied these U's all the way down before I go any further because those will never change. multiplying by 1, these are going to stay the same. And now I'm adding 1. Again, undefined stays undefined. These will all go up by 1. First thing I'm going to do when I go to the graph is I'm going to graph my asymptotes. So I have an asymptote at 0. And I have an asymptote of 4 pi. I can't see 4 pi on the scale that I have, so now I'm going to change my scale so I can see a little bit more what's going on. So let's say I make this, well, let's make this pi, this 2 pi, this 3 pi, and we'll make this one 4 pi. Going the opposite direction, negative pi, negative 2 pi, negative 3 pi, and finally negative 4 pi. When I go, so I have an asymptote at 0, and then I also have another asymptote at 4 pi. And if I'm counting, I have 1, 2, 3, 4, 5, 6, 7, 8. So going the other direction, 1, 2, 3, 4, 5, 6, 7, 8. And I didn't want to do that. And I have, why is it not being aligned? There we go. I have another asymptote at negative 4 pi. So when I go to write my vertical asymptotes, I'm going to write negative 4 pi, 0, and positive 4 pi. Sketching the graph at pi, I'm going to sketch 2. So at pi, I sketch 2. At 2 pi, I sketch 1. And at 3 pi, I sketch 0. Again, it almost touches the asymptote, goes through these 3 dots, and then goes down. The one over here, 1, 2, 3, 4, 5, 6, 7, 8, the one in the middle, I'm going to have up here and here, touches the asymptote, goes through those dots, and then tries to touch the other asymptote. And that will be the graph of my 1 plus cotangent 1 fourth x. So you have a couple more to practice for tangent and cotangent. And now let's look at secant and cosecant. I graph secant and cosecant for you over here. So you could have an idea of what they look like. Again, completely different shape. These look like a bunch of little parabolas, I guess is the best way to describe it. Some are going up, some are going down. And then what you really can't see, but I'm going to tell you that are there, is you do have vertical asymptotes in between those. So you have a vertical asymptote here and a vertical asymptote here. On the cosecant one, you have a vertical asymptote here and a vertical asymptote here. Well, that's a really not straight line. So the first thing I notice is in order for me to see one complete shape, in other words, an up parabola and a down parabola, in order for me to see one complete shape, so here I have this up parabola, and then I have this down parabola. That looks like it's going from about negative pi over 2 to 3 pi over 2. Let's check the one that's below, the cosecant. That one starts at 0. Here's my up parabola. Here's my down parabola. It takes me 2 pi for me to get one complete cycle in. So when I go to do secant and cosecant, my normal period is going to go back to 2 pi. Both secant and cosecant. And I'm still going to divide it by b to find out whatever my new period is. Then to find my step, I'm going to take whatever that new period is and divide it by 4. And now tell me how much I add to my graph. Now, cosecant, I'm going to talk about cosecant first. This cosecant, it's easy that I start an asymptote at 0. So I'm going to set whatever's inside that parenthesis, I'm going to set equal to 0. When I go to do the other one, I am tempted to start it at 0. I'm sorry, not 0. I'm tempted to say it started because this is negative pi over 2, and this is positive 3 pi over 2. And I might want to start it at negative pi over 2, but if I do, I might have problems graphing it later on. So we're going to end up starting it at 0, knowing that we're starting it halfway through a parabola, I guess is the best way to say it. So I'm still going to write my starting point as bx minus c is equal to 0. because that'll help me out later on. And I'm just going to have an asymptote in the middle of my, which will be fine. My end is going to be dx minus c is equal to 2 pi. Dx minus c is equal to 2 pi. The only ones that have a period of pi are cotangent and tangent. Everything else has a period of 2 pi. When I go to do my y term, secant, going up here, secant is 1 over cosine, yes? So my cosine pattern, and I'm just going to write this really tiny here, my cosine pattern was 1, 0, negative 1, 0, 1. We just finished taking a quiz on that. So when I go to find this y pattern, anywhere where it's 0, since I'm taking the reciprocal, it's going to be undefined. And then I'm going to take the reciprocal of these other ones. Well, the reciprocal of 1 is 1. The reciprocal of negative 1 will be negative 1. The reciprocal of 1 is 1. So this is my new y pattern for secant. Is going to be, and I do have the undefined in the middle, which I'm okay with. It'll make life easier later on. So when I go to do cosecant, that's 1 over sine. Well, the pattern for sine was 0, 1, 0, negative 1, 0. That was sine. Now to do the cosecant, anything that has a 0 will be undefined. And then take the reciprocal of 1, take the reciprocal of negative 1. So this is your y pattern for cosecant. Again, you're gonna do a bunch. You're gonna start to memorize them, and it'll be great. So let's do one. Let's do two. We'll do one of each. So I'm gonna first do I'm gonna do negative 3 cosecant x. Okay, so we have y is equal to negative 3 cosecant x, and that's the one I wish to graph. So I'm going to identify my A. Whoopsie. My A is negative 3. My B is 1. My C is 0. My D is 0. So to find my period, I take 2 pi and divide it by 1, and I end up with 2 pi. To find my step, I take that new period of 2 pi and I divide it by 4, and I end up with pi over 2. To find my start, I take whatever's in that parenthesis and I set it equal to 0. So I'm going to have x is equal to 0. The only one you have to remember not to set equal to 0 is tangent. To find my end, I take whatever's in that parenthesis and set it equal to 2 pi. So this start, I'm going to start at 0. I'm going to go up by pi over 2. I'm happy because my end matches my end. To find my horizontal shift, I'm going to take I'm going to take horizontal shift. I'm going to take my C, which is 0, and divide it by my B, which is 1, and I'm going to end up with 0. My vertical shift is whatever I'm adding or subtracting on the outside. That also happens to be 0. My y pattern, if you know, again, you're going to get good at these and you're going to memorize them, but I'm doing cosecant. My y pattern is u1, u, negative 1, u. So remember, the u's you fill straight across because they will never, ever change. Then A is negative 3, so I'm going to take negative 3 times my y column, so this will be negative 3. This will become positive 3. My D was 0, so I'm not adding anything, so that negative 3 and 3 will stay the same. First thing I do when I do these is I put in my vertical asymptotes. So I'm going to have a vertical asymptote at 0, a vertical asymptote at pi, a vertical asymptote at 2 pi. If I count, I have 4 lines in between, so I'm going to count 4 lines, 1, 2, 3, 4, vertical asymptote at negative pi, vertical asymptote at negative 2 pi. And I'm only going to be graphing 2 points. One of those points I'm graphing is pi over 2, negative 3. So pi over 2, negative 3. I have that dot there. And then the other one is 3 pi over 2, positive 3. 3 pi over 2, positive 3. Now, if you go back to the graphs when I first did this, you can see that you have these little parabolas. So I just found the vertexes of those parabolas is what I just found. I found the point of the vertex. So I am going to go and I'm going to graph parabolas. So this one has to open down because it has to open in the opposite direction of the other dots, if that makes sense. So these two, this one and this one, have to open away from each other. Now when I go over here, I'm going to hit the middle point. I'm going to want to put that dot here so it goes every other one. So you have, so what I'm saying here is I have a low parabola, then I have a high parabola. Low parabola, high parabola, and you have to alternate with that. And that is my graph of -3 cosecant x. And finally, we're going to do one where we have a horizontal shift. So that's this one here. Y is equal to, this is number 16 on your packet. Y is equal to 3 secant x minus pi over 2. So again, my A is 3. My B is 1. My C is pi over 2. Remember, it's whatever you're subtracting from the x. And my D is 0. So to find my period, I'm going to take 2 pi, and I'm going to divide it by b, which is 1, so I end up with 2 pi. To find my step, I take that 2 pi and divide it by 4, and I end up with pi over 2. To find my start, I take whatever is inside that parenthesis, and I set that equal to 0. So I am going to say that x minus pi over 2 is equal to 0. I add pi over 2 to both sides, and I get x is equal to pi over 2. My n is going to be x minus pi over 2 is equal to 2 pi. So when I add that would be x is equal to 5 pi over 2. This start comes down here. My step is pi over 2, so I'm going to add pi over 2 each time. Then it's secant, and my pattern for secant, if you have to go back and look, you go back and look, and eventually you should memorize. Secant is the one that does not start with the undefined. So I start with the 1. So I start 1 undefined, -1 undefined, 1. That is my y pattern. I take a times that, but remember the u's go straight across. They will never change. 1 times 3 is 3. -1 times 2 is -3, and then 3. I had no d, or my d was 0, so I'm just going to fill in these. Okay, first thing I'm going to graph is my asymptotes. So I am going to graph an asymptote at pi. And I'm going to graph an asymptote at 5 pi over 2, which would be about here. So now I know that it is, oh, I lied to you. I lied to you. Why did I lie to you? This asymptote is actually at 2 pi. Let me move that to 2 pi. I read my chart wrong. So I see when I count lines, and I like counting lines, count, there's 1, 2, 3, 4 in between, 1, 2, 3, 4. I'm going to have one at 0.
Ms. Amy Myers, please call extension 1100.
1, 2, 3, 4. 1, 2, 3, 4. And the reason why I have this asymptote at 0, because remember that's the whole reason why we were talking about having, you know, the shift and everything like that. The reason why I have this is because I had that horizontal shift, and that's why I have that asymptote at 0. I'm going to plot these points, pi over 2, 3. 3 pi over 2, -3. And then the other one would be over here somewhere, a little bit over, and it would be up here. Remember, I have a dot here and I have a dot here. I have 2 parabolas. They have to open up in opposite directions of each other, which means this one has to open down. This one has to open up. Those 2 parabolas cannot be overlapping each other when I look horizontally. Next one in the middle, I'm going to put here. It's going to open down. Some alternating, which means that this one will have to open up. And then this one, I guess I could do it without half, but I want to. Vertical asymptotes on my graph are going to be -2 pi, negative pi, 0, pi, and 2 pi. Okay, so that's graphing sine, that's graphing tangent, cotangent, secant, and cosecant. Oh, forgot my vertical and horizontal shifts. Whoopsie. So my horizontal shift is going to be my c, which is pi over 2, divided by b, which is 1, and I end up with pi over 2. My vertical shift is my d. My d was 0, so my vertical shift is d. So that's it. Hope that helped, and go do the packet.